Today's lesson is on solving square root equations. By the end of this lesson, you should be able to solve radical equations. To solve radical equations, isolate the radical, or one of the radicals, to one side of the equal sign. Hint, undo PEMDAS, meaning undo add or subtract, then undo multiply divide, undo the exponents, and then undo the parentheses. If a radical is a square root, square each side of the equation. If the radical is not a square root, raise each side to the power equal to the index of the root. So to undo a cube root, you're going to cube. To undo a fourth root, you're going to raise it to the fourth power. And remember, if you are squaring a binomial, remember to write it twice and use the box method to multiply. Then solve the resulting equation, and please do not forget to check. So, solve each of the following square root equations, which are arranged from less to more complex. Check each equation. Remember, the directions are not going to say to check. So, in the first one, the radical is isolated, so that was our first step. Now, to undo the square root, we're going to square both sides. So square root squared, those cancel, those undo each other. So we have x equals 7 squared, which is 49. When you grab your calculator and you check that, the square root of 49 is 7. So we are good to go. In part B, again, the radical is isolated because there's nothing added, subtracted, multiplied, or divided to the radical. Under the radical there is, but we can't do anything to that until we get rid of the radical. So we're going to, again, square both sides. So 2x minus 1 equals 16. Now I have to add 1. So 2x equals 17. Divide by 2. So x equals 17 halves. So let's refresh your memories on how to check an equation. So on my calculator page, I'm going to store 17 halves as my variable x by hitting the Control var button, x, enter. Now I'm going to put the equation in, or the expression, the left side, which is 2x minus 1. And when I hit enter, hopefully it equals 4. And it does. So I know that this is true, and it checks. That's my answer. In letter C, I have the first of the more complex ones. I have to isolate the radical. So the radical is not alone on the side. So how do I get it alone? Well, first I have to undo minus 4. So plus 4. So 3 radical x equals 24. Then I have to undo the 3 times the radical, so I divide by 3. So the square root of x equals 8. Now how do I undo the radical? I square it because the index, remember, of just the square root is 2. That's why I raise it to the power of 2. So square root and squared undo each other, so x equals 64. So again, just to refresh your memories, I'm going to store 64 for x, and I'm going to plug in the expression on the left side. So 3 square root of x, get out of the square root, minus 4. And when I hit enter, hopefully it equals 20. And it does. If there was another expression on the right side, I would have to plug that in and see if they're equal. But since it's just a constant, I just want this to equal the other side, which it is 20. So my answer to 64 is also true, so I'm good to go. Alright, so why don't you pause the video and try D? D is just like C. And don't forget to check your answer. So hopefully you got for letter D, 22. So I had to do a lot of isolating to get the radical alone. Once I squared it, I had to then isolate the x. So my answer was 22, and it most certainly does check. So now the next two are going to give us that 2B, I guess, warning at the top about squaring binomials. So please, please, please make sure that you are paying attention and you star this. So in the first one, step one is to isolate the radical. Well, the good news is we're back to it is already isolated. So how do I undo the radical? I square. So I'm going to square both sides of the equation. Now this is a binomial, two terms. So back up at the top when it said that if you are squaring a binomial, remember to write it twice. So x minus 3 times x minus 3. And use the box method to multiply. So off to the side, I'm going to draw my box because I have a binomial and a binomial. That's a 2 by 2. So I have x minus 3 and an x minus 3. Every term gets its own column and its own row. X times x is x squared. X times negative 3, negative 3x. X times negative 3, negative 3x. Negative 3 times negative 3 is positive 9. Now remember, these two are like terms. So I have x squared minus 6x plus 9. Alright, so I'm going to write that up here. X squared minus 6x plus 9 equals, well, square root and squared undo each other. So 2x plus 3. Just like we've said many times before, as soon as I have an exponent, I'm going to want to get it equal to 0 and factor. So I'm going to subtract 2x and subtract 3, subtract 2x and subtract 3, and notice I put them under the like terms. So x squared stays the same, negative 6x and negative 2x is negative 8x, 9 minus 3 is positive 6. So I need to figure out what multiplies to 6 and adds to 8. Looks like I caught my mistake because there are no multiples of 6 that add to 8. I changed that to a plus 3. This should have been a minus 3, not a plus 3. So then this should have been a plus 3. So this should be a plus 12. So what multiplies to 12 and adds to 8? And your answer is, and remember, since this is a plus 12, the signs are the same. So we have x and x. 6 and 2 multiply to 12, and negative 6 and negative 2 give me 8. So now I'm going to set each factor equal to 0 and solve. So x equals 2 and x equals 6. So I'm going to grab my calculator and check. And you'll notice I did this check a little bit different because I wanted to talk about an alternative way to solve these. If you got in a jam and you couldn't remember how to solve them, you could always solve it graphically. When you solve something graphically, make sure you label everything. Label all 4 of your axes. Label both of your graphs and label the intersection. So you'll notice I only have one intersection, and at that intersection, x equals 6. Also, when you solve graphically, don't forget to write the answer. So your only answer is 6. So back here, I'm going to reject the 2. And the 6 is true, so the 6 is my only answer. Okay, so another way to check would be to do it graphically on your calculator. So you can either store to check or do it graphically. In letter F, our radical is not isolated, so that's the first thing we must do is add the 2. And 2 is not like 2x, so I have 2x plus 2, which is a binomial, equals the square root of x plus 6. To get rid of the radical, I'm squaring both sides. This is a binomial, so I'm going to write it twice. And then off to the side, I'm going to make my 2 by 2 box. 2x plus 2, 2x plus 2. So 2x times 2x is 4x squared. 2x times 2 is 4x. 2x times 2 is 4x. 2 times 2 is 4. Your middle terms add up again, so we have 4x squared plus 8x plus 4. So 4x squared plus 8x plus 4 equals x plus 6. These questions are a lot of work, so you definitely want to practice a lot of these. I'm going to get it equal to 0 and factor because I have a power. So I have 4x squared plus 7x minus 2 equals 0. The downfall to this one is this is not the easy kind of factoring. This is the AC box method, so I have to do another box, but this time I'm going backwards. I have the insides and I've got to find the factors on the outsides. So a times c is -8, so my signs are different. My b value is 7, so I have a +8 and a -1. I'm running out of room. So I have 4x squared positive 8x, -1x, and -2. GCF is x, GCF is 2, GCF is 4x, and that works. This is a +2 because +2 and 4x gives me a +8x. This has two negatives, so that would be a -1. Check all my pieces. I'm good. So my factors are 4x minus 1 and x plus 2 equals 0. Therefore, my answers, x equals 1/4 and x equals -2. I'm going to grab my calculator and check, so why don't you pause the video and do so. And you'll notice on my check that 0.25 is my only intersection. So back at my answers, x equals 0.25, which is the same as 1/4, and -2 is a reject. So this one was true. And I like to write true under it to remind myself that I did check. So my only answer to letter F is 1/4 or 0.25. All right, so let's try exercise 2. It looks like it's graphing, so grab your calculator again. All right, hopefully you graphed the two equations, functions. I labeled them 1 and 2 so that my graph wasn't cluttered up by their equations. I solved this system of equation graphically because the answer is where they intersect, and that intersection is 1, 2. And now it tells me to solve it algebraically. And it asks me for only the x values using substitution below. So I know they're both equal to y, so therefore they're equal to each other. Notice again, the radical is isolated, so I'm going to square both sides. I'm going to write this binomial twice, and I'm going to use my box to multiply. So I have x squared plus x plus x plus 1. So I have x squared plus 2x plus 1. So x squared plus 2x plus 1. Hopefully you're really good at doing that now. Equals squared and square root cancel each other or undo each other. So I have x plus 3. I have a power, so I want to get it equal to 0 so I can factor. And I'm going to line up the like terms there. So I have x squared plus x minus 2. The good news is it's an easier trinomial. So what multiplies to -2 and adds to 1? So we have x and x. You should be saying 2 and 1. +2, -1. Set my factors equal to 0. I get x equals 1 and x equals -2. Now, it's a system of equations. I have two variables. So when I plug them back in, let's say I do the line, then I have y equals 1 plus 1, so y equals 2, so my ordered pair is 1, 2. And then I plug in y equals -2 plus 1, so y equals -1, so I have -2, -1. And the question is, why does your answer from part A contradict what you found in part B? And what do you think? Well, I used the line to find the y values. And remember, a radical in this problem, the radical has to equal a positive number because there's nothing in front of this radical, so it needs to be positive. So y has to be positive. Well, y is clearly not positive here, so it doesn't intersect. And if you look at our graph, our domain is all greater than -3, which was okay, but our range has to be greater than 0, and it is not. So this would be a reject because it wouldn't check in both of them. Okay. Good luck with this. Hope you can solve these equations relatively easy. If not, ask in class.